Hi everyone, this is our product Smart Survey, and we're going to answer the question of how can the UK source 50% of its energy from the seabed by 2050? So we started off with some market research. We wanted to find out exactly what the problems our stakeholders faced were, and first this involved prompting the different GPTs as well as talking to these people in person to find out what the main difficulties they found in existing solutions. We found some common themes between what our stakeholders brought up. For example, Aruj, the head of emerging technology and innovation, said that we have a lot of data, but we're not generating the actions we need quickly enough.
Liv says that we have to consider multiple factors such as seabed biology or biodiversity, and that making it all accessible is a challenge.
Will felt it was vital that we implement new data sources such as drones or satellite imagery to improve the efficiency. We concluded that the main issue in seabed energy is in fact not actually building the turbines, but rather surveying the seafloor sites. The current method is slow, involving strapping sensors to the bottom of boats and planes. Our software massively reduces the area to be surveyed.
In order to find our solution, we identified the common themes, which included the need for quicker action from data insights, the complexity of making data accessible, and the potential of innovative data sources like satellite imagery to improve surveying efficiency.
We use a modified Dijkstra's algorithm to ensure that our software creates efficient routes. Penalties are imposed on areas of strong wind, which may influence the drones. Smart Survey is incredibly user-friendly, allowing users to drop and drag pins wherever they like. After that, the software will take care of the rest, plotting routes to avoid wind while maintaining a optimal path, increasing the efficiency.
So rather than clutter the interface with all of the available information about the geography and ecology of the seabed, we opted to keep things more accessible and simple, and feed all of this complex data into a large language model instead. So our chatbot, which is using GPT-4o, can use its retrieval and generation API to find the relevant data it needs about our route. And this means that we can let the user talk to the route directly and prompt for some of this complex information. So for example, if you look at the image here, you can see the user asks if the drone passes by any conservation routes. And at that point, the chatbot can retrieve this information and give it back to the user.
Tenfold.
So the model also has function calling, meaning that you can make changes to the route when necessary. In our software, you can drag around the waypoints to create the route that you want. You can set the start and end locations of surveying. After that, you can talk to your route and ask questions about ecology and the geography of the route. As you can see, the chatbot can retrieve specific information about your route and any problems you might encounter. On top of that, the chatbot has great general knowledge, so you can ask general questions about different wildlife and species in the area.
Additionally, in real time, you can observe the wind data affecting your surveilled drone flight easily with this map. Thank you for your attention, and we hope you share our enthusiasm in harnessing seabed energy